Efficiency equals 80%, which is 80 over 100, so that's 0.8. Yeah. Efficiency is equal to out over in. Yeah. So 0.8 is equal to 20 kilowatts divided by the input. You rearrange that. So in comes up there, 0.8 goes down there. Input must be the 20 kilowatts divided by 0.8. Now you're going to have your input more than your output. 25 kilowatts. Yeah. Now you can find your current. What other value have I given you? V, haven't I?
Voltage. Yeah.
So we got power, voltage, we want current. IV then. Yeah. Therefore, I equals P over V, 25,000 divided by 200, wasn't it?
Yeah.
125 amps. So I chucked a bit of a curveball in there because everybody should know efficiency is out over in.
No.
Yeah.
Everybody didn't know.
Alright?
Yeah.
You know now.
Yeah.
Yeah. But that don't matter what you're talking about, mechanical stuff, mechanical power, electrical power, efficiency, output over input.
Yeah. Think about it. Stand back and see the pictures of figures.
Yeah. But flagging up as soon as you're getting more out than you're putting in,
yeah,
should flag up. There's something wrong there somewhere. Perpetual motion. As soon as you've got getting more out than you're putting in, you've effectively invented perpetual motion. Because you can use the spare output to keep it running. That don't work, does it? Right? Fundamental laws of physics and all that. Right, we'll move on a little bit, gentlemen. So you've got more than one route for current. More about that later. R1 and resistors only. For become 3 or more close the brackets, and what you mustn't miss is the bracketed term is also to the -1. When you get enough so I tend to prefer it in that form, and all that effectively is the reciprocal. All total power always a parallel by that last bit. Can have is 2 different general types of combination where series with a third, or to two different combinations. Now, there isn't a... I could write a formula for doing all that in one go, okay? But if it gets bigger than that, trying to do it all in one go, there isn't a standard formula. You have to make it up from the series and parallel formulae, and it would get very messy. Okay? I mean, this one... I could probably like that. Those two in series add up to 10, and then you've got those two in parallel, so you're going to half it. So all of that is 5. That's 10. 2 in parallel. Yeah, 2 10s in parallel make 5. Yeah. 10 stays as it is. 2 20s in parallel make a 10. 5 plus 10 plus 10 is 25. Yeah, what I've used that version, that one at the end there, the same value. So there's 2 of them divided by the value. So it's 2 10s. 10 divided by 2 is 5. On the end, 2 20s. 20 divided by 2 is 10. Yeah. So when
I took the RP as
it's just R of the parallel combination. They're all the same. Yeah. $200, 125, 60, 75, 80 and 40. It's a process of breaking it down until we end up with either, we've got formulas for series, we've got formulas for parallel. So we're breaking it down, simplifying it until we end up with either all series or all parallel, and then we can find the tuple. So we go these two as R1 plus R2 equals 200 plus 125 plus 325 ohms. So what we're saying there is these two make 325. So I could take those two, what we're saying there is you could take those two resistors out, replace them with a 325, and exactly the same current would flow everywhere in that circuit. Yep. Then we can together Daniel. That whole bit from there in the smaller than the smallest. Yes, it's less than 60. Right? That 75 can be left as it is. We now need to do this one.
Right.
So